to 300 and the 757 to 200. In June 1986, Boeing announced the development of the 737 to 400, which stretched the fuselage a further 10 feet, 3.0 m, increasing the capacity to 188 passengers, and requiring a tail bumper to prevent tail strikes during takeoff and a strengthened wing spar. The -400's first flight was on the 19th of February 1988, and, after a 7-month forward/500-hour flight testing run, entered service with Piedmont Airlines that October. The last two -400's, i.e. the last 737 Classic Series, were delivered to CSA Czech Airlines on the 28th of February 2000. The 737 to 400 was replaced by the 737 to 800 of the next generation series. The 737-400SF was a 737 to 400 converted to freighter, though it was not a model delivered by Boeing and hence the nickname Special Freighter, SF. Alaska Airlines was the first to convert one of their 400's from regular service to an aircraft with the ability to handle 10 pallets. The airline had also converted 5 more into fixed combi aircraft for half-passenger and freight. These 737 to 400 combi aircraft were retired in 2017 and replaced by the 737-700F of the next generation series. 737-500, edit. The 737 to 500 was offered as a modern and direct replacement of the 737 to 200. It was launched in 1987 by Southwest Airlines, with an order for 20 aircraft, and it flew for the first time on the 30th of June, 1989. A single prototype flew 375 hours for the certification process, and on the 28th of February, 1990, Southwest Airlines received the first delivery. The -500 incorporated the improvements of the 737 Classic Series, allowing longer routes with fewer passengers to be more economical than with the 737 to 300. The fuselage length of the 737 to 500 is 1 foot 7 inches, 48 centimeters, longer than the 737 to 200, accommodating up to 140 passengers. Both glass and older-style mechanical cockpits arrangements were available. Using the CFM56-3 engine also gave a 25% increase in fuel efficiency over the older 737-200 SP and W engines. The 737 to 500 has faced accelerated retirement due to its smaller size, after 21 years in service compared to 24 years for the -300. While a few 737-300s were slated for freighter conversion, no demand at all existed for a -500 freighter conversion. The 737 to 500 was replaced by the 737 to 600 of the next generation series, though the -600 was not as successful in total orders as the -500. 737 Ing, third generation, edit. Main article, Boeing 737 Next Generation. The Boeing 737 Next Generation, abbreviated as 737 Next Gen or 737 Ing, is the name given to the main model 737-600/700/800/900 series and the extended range -700/900 variants of the Boeing 737 family. It has been produced since 1996 and introduced in 1997. with a total order of 7,097 aircraft, of which 7,031 have been delivered as of May 2019. The primary goal was to re-engine the 737 with the high-pressure ratio CFM 56-7. By the early 1990s, as the MD-80 slowly withdrew from the competition following the introduction of the MD-90, it had become clear that the newer 320 family was a serious threat to Boeing's market share. Airbus won previously loyal 737 customers, such as Lufthansa and United Airlines. In November 1993, to stay in the single-aisle competition, Boeing's board of directors authorized the next generation program to mainly upgrade the 737 Classic series. In late 1993, after engineering trade studies and discussions with major customers, Boeing proceeded to launch a second derivative of the Boeing 737, the 737 Next Generation, Ing. -600/700/800/900 series. It featured a redesigned wing with a wider wingspan and larger area, greater fuel capacity, longer range and higher MTOWs. It was equipped with CFM 56-7 high-pressure ratio engines, a glass cockpit, and upgraded interior configurations. The four main models of the series can accommodate seating for 108 to 215 passengers. It was further developed into additional versions such as the corporate Boeing Business Jet, BBJ, and military P-8 Poseidon aircraft. Following the merger between Boeing with McDonnell Douglas in 1997, the primary competitor for the 737 series remained only the A320 family. 737-600, edit. The 737-600, the smallest model of the next generation, was launched by Scandinavian Airlines, SAS, in March 1995 with the first aircraft delivered in September 1998. A total of 69 aircraft without winglets have been produced, with the last one delivered to WestJet in 2006. The 737-600 replaced the 737-500 and is similar to the Airbus A318. 737-700, edit. The 737-700, the first variant of the next generation, was launched in November 1993 with an order of 63 aircraft. The -700 seats 126 passengers in a 2-class or 149 passengers in a 1-class layout. The launch customer Southwest Airlines took the first delivery in December 1997. The 737-700 replaced the 737-300 and competes with the Airbus A319. The 737-700C is a convertible version where the seats can be removed to carry cargo instead. There is a large door on the left side of the aircraft. The United States Navy was the launch customer for the 737-700C under the military designation C-40 Clipper. The 737-700 extended range was launched on the 31st of January 2006 and featured the fuselage of the 737-700 and the wings and landing gear of the 737-800. A 737-700 can typically accommodate 126 passengers in 2 classes with a range similar to the Airbus A319LR. 737-800, edit. The 737-800 was a stretched version of the 737-700 launched on the 5th of September 1994. The -800 seats 162 passengers in a 2-class or 189 passengers in a high-density, 1-class layout. Launch customer Hapag-Lloyd Flug, now TU Italy, received the first one in April 1998. The -800 replaced directly the -400 and aging 727-200 of U.S. airlines. It filled also the gap left by Boeing's decision to discontinue the MD-80 and MD-90 aircraft, following Boeing's merger with McDonnell Douglas. The 737-800 is the most widely used narrow-body aircraft and competes primarily with the Airbus A320. 737-900, edit. The 737-900 was launched in 1997 and took its first flight on the 3rd of August, 2000. It retains the MTO, fuel capacity, trading range for payload and also the exit configuration of the -800, limiting its seat capacity to approximately 177 in a 2-class and 189 in a high-density, 1-class layout. The launch customer Alaska Airlines received the delivery on the 15th of May, 2001. The 737-900 extended range, is the newest and largest variant of the 737 generation. An additional pair of exit doors and a flat rear pressure bulkhead increased its seating capacity to 180 passengers in a 2-class and up to 220 passengers in a 1-class configuration. The -900 was introduced to meet the range and passenger capacity of the discontinued 757-200 and to directly compete with the Airbus A321. 737 MAX, 4th generation, edit. Main article, Boeing 737 MAX. The Boeing 737 MAX is the name given to the main model 737 MAX 7/8/9/10 series and the higher density MAX 200 variant of the Boeing 737 family. It is offered in 4 main variants, typically offering 138 to 230 seats and a range of 3,215 to 3,825 nautical miles, mi. 5,954 to 7,084 kilometers, 3,700 to 4,402 mi. The 737 MAX 7, MAX 8, including the denser, 200-seat MAX 200, and MAX 9 replace the 737-700, -800, and -900 respectively. The further stretched 737 MAX 10 has also been added to the series. The main development was to re-engine with CFM LEAP 1B very high bypass ratio. On the 20th of July, 2011, Boeing announced plans for a third major upgrade and respectively 4th generation of 737 series to be powered by the CFM LEAP 1B engine, with American Airlines intending to order 100 of these aircraft. On the 30th of August, 2011, Boeing confirmed the launch of the 737 new engine variant, to be called the Boeing 737 MAX. It was based on earlier 737 designs with more efficient LEAP 1B power plants, aerodynamic improvements, most notably split-tip winglets, and airframe modifications. It competes with the Airbus A320neo family that was launched in December 2010 and reached 1,029 orders by June 2011, breaking Boeing's monopoly with American Airlines, which had an order for 130 A320neos that July. The 737 MAX had its first flight on the 29th of January 2016, and gained FAA certification on the 8th of March, 2017. The first delivery was a MAX 8 on the 6th of May, 2017, to Lion Air's subsidiary Malindo Air, which put it into service on the 22nd of May, 2017. As of January 2019, the series has received 5,011 firm orders. In March 2019, civil aviation authorities around the world grounded the 737 MAX following two hull loss crashes which caused 346 deaths. On the 16th of December 2019, Boeing announced that it would suspend production of the 737 MAX from January 2020, which was resumed in May 2020. In the mid-year 2020, the FAA and Boeing conducted a series of recertification test flights. On the 18th of November 2020, the FAA cleared the MAX to return to service. Before the aircraft can fly again, repairs must be implemented and airlines' training programs must be approved. Passenger flights in the US are expected to resume before the end of the year. Worldwide, the first airline to resume passenger service was Brazilian low-cost Gol, on the 9th of December 2020. 737 MAX 7, edit. The 737 MAX 7, a shortened variant of the MAX 8, was originally based on the 737-700, flying 1,000 nautical miles, 1,900 kilometers, 1,200 mi, farther and accommodating two more seat rows at 18% lower fuel costs per seat. The redesign uses the 737 to 8-wing and landing gear, a pair of over-wing exits rather than the single-door configuration, a 46-inch longer, 1,200 mm, aft fuselage and a 30-inch longer, 760 mm, longer forward fuselage, structural regauging and strengthening, and systems and interior modifications to accommodate the longer length. Entry into service with launch operator Southwest Airlines was expected in January 2019, but the airline deferred these orders until 2023-2024. The 737 MAX 7 replaced the 737-700 and was predicted to carry 12 more passengers and fly 400 nautical miles, 740 kilometers, 460 mi, farther than the competing Airbus A319neo with 7% lower operating costs per seat. 737 MAX 8, edit. The 737 MAX 8, the first variant of the 737 MAX, has a longer fuselage than the MAX 7. On the 23rd of July, 2013, Boeing completed the firm configuration for the 737 MAX 8. Its first commercial flight was operated by Malindo Air on the 22nd of May, 2017. The MAX 8 replaced the 737-800 and competed with the A320neo. The 737 MAX 200, a high-density version of the 737 MAX 8, was launched in September 2014 and named for seating for up to 200 passengers in a single-class layout with slimline seats requiring an extra pair of exit doors. The MAX 200 would be 20% more cost-efficient per seat, including 5% lower operating costs than the MAX 8, and would be the most efficient narrow-body on the market when entering service. In mid-November 2018, the first MAX 200 of the 135 ordered by Ryanair rolled out, in a 197-seat configuration. It was first flown from Renton on the 13th of January, 2019, and was due to enter service in April 2019. 737 MAX 9, edit. The 737 MAX 9, the stretched variant of the MAX 8, was launched with an order of 201 aircraft in February 2012. It made its rollout on the 7th of March 2017, and first flight on the 13th of April 2017. It was certified by February 2018. The launch customer, Lion Air Group, took the first MAX 9 on the 21st of March 2018, before entering service with Thai Lion Air. The 737 MAX 9 replaced the 737-900 and competes with the Airbus A321neo. 737 MAX 10, edit. The 737 MAX 10 was proposed as a stretched MAX 9 in mid-2016, enabling seating for 230 in a single class or 189 in two-class layout, compared to 193 in two-class seating for the A321neo. The modest 66-inch, 1.7 m, stretch of fuselage enables the MAX 10 to retain the existing wing and CFM LEAP 1B engine from the MAX 9 with a trailing link main landing gear as the only major change. The MAX 10 was launched on the 19th of June, 2017, with 240 orders and commitments from more than 10 customers. The variant configuration with a predicted 5% lower trip cost and seat cost compared to the A321neo was firmed up by February 2018, and by mid-2018, the critical design review was completed. The MAX 10 has a similar capacity to the A321XLR, but shorter range and much poorer field performance in smaller airports. It was unveiled in Boeing's Renton factory on the 22nd of November, 2019, and scheduled for first flight in 2020. Boeing also considered parallel development with the 757 replacement, similar to the development of the 757 and 767 in the 1970s. In the late 2010s, Boeing worked on a medium-range Boeing new midsize airplane, NMA, with two variants seating 225 or 275 passengers and targeting the same market segment as the 737 MAX 10 and the Airbus A321neo. A future small airplane, FSA, was also touted during this period. The NMA project was set aside in January 2020, as Boeing focused on returning the 737 MAX to service and announced that it would be taking a new approach to future projects. Design, edit. The 737 continued to evolve into many variants but still remains recognizable as the 737. These are divided into 4 generations but all are based on the same basic design. Airframe, edit. The fuselage cross-section and nose are derived from that of the Boeing 707 and Boeing 727. Early 737 cockpits also inherited the eyebrow windows positioned above the main glare shield, which were a feature of the original 707 and 727 to allow for better crew visibility. Contrary to popular belief, these windows were not intended for celestial navigation. Only the military T-43 had a sextant port for star navigation, which the civilian models lacked. With modern avionics, the windows became redundant, and many pilots placed newspapers or other objects in them to block out sun glare. They were eliminated from the 737 cockpit design in 2004, although they are still installed on customer request. The eyebrow windows were sometimes removed and plugged, usually during maintenance overhauls. and can be distinguished by the metal plug, which differs from the smooth metal in later aircraft that were not originally fitted with the windows. The 737 was designed to sit relatively low to the ground to accommodate the design of smaller airports in the late 1960s, which often lacked jet bridges or motorized belt loaders. The low fuselage allowed passengers to easily board from a mobile stairway or air stairs, which are still available as an option on the 737 MAX, and for luggage to be hand-lifted into the cargo holds. However, the design has proved to be an issue as the 737 has been modernized with larger and more fuel-efficient engines. The 737's main landing gear, under the wings at mid-cabin, rotates into wheel wells in the aircraft's belly. The legs are covered by partial doors, and brush-like seals aerodynamically smooth, or fair, the wheels in the wells. The sides of the tires are exposed to the air in flight. Hubcaps complete the aerodynamic profile of the wheels. It is forbidden to operate without the caps, because they are linked to the ground speed sensor that interfaces with the anti-skid brake system. The dark circles of the tires are clearly visible when a 737 takes off, or is at low altitude. From July 2008, the steel landing gear brakes on new wings were replaced by Messier Bugatti carbon brakes, achieving weight savings to 5,700 pounds, 253.20 kg, depending on whether standard or high-capacity brakes were equipped. On a 737-800 this gives a 0.5% improvement in fuel efficiency. 737s are not equipped with fuel dump systems. The original design was too small to require this, and adding a fuel dump system to the later, larger variants would have incurred a large weight penalty. Boeing instead demonstrated an equivalent level of safety. Depending on the nature of the emergency, 737s either circle to burn off fuel or land overweight. If the latter is the case, the aircraft is inspected by maintenance personnel for damage and then returned to service if none is found. 1. The original 737 with JT8D engines that span the entire wing chord. 2. The 737 Classic with larger CFM56 engines mounted mostly ahead of the wing. 3. The 737 with improved CFM56-7 engines. 4. The 737 MAX has larger CFM LEAP engines with chevrons, mounted even further ahead of the wing. Engines, edit. Engines on the 737 Classic series, -300, -400, -500, and next generation series, -600, -700, -800, -900, do not have circular inlets like most aircraft but rather a planform on the lower side, which has been dictated largely by the need to accommodate ever larger engine diameters. The 737 Classic series featured CFM56 high bypass turbofan engines, which were 25% more efficient and also reduced noise significantly over JT8D low bypass engines used on the 737 original series, -100 and -200, but also posed an engineering challenge given the low ground clearance of the Boeing 737 family. Boeing and engine supplier CFM International, CFMI, solved the problem by placing the engine ahead of, rather than below, the wing, and by moving engine accessories to the sides, rather than the bottom, of the engine pod, giving the 737 Classic and later generations a distinctive non-circular air intake. The improved, higher pressure ratio CFM56-7 turbofan engine on the 737 next generation is 7% more fuel efficient than the previous CFM56-3 on the 737 Classic with the same bypass ratio. The newest 737 variants, the 737 MAX series, feature LEAP 1B engines from CFMI with a 69 inches, 1.76 m, fan diameter. These engines were expected to be 10 to 12% more efficient than the CFM 56-7B engines on the 737 next generation series. 737-200 JT8D engine with original cowling design. 737-400